Good morning, students. In the third part of correlation, today we are going to discuss in detail Spearman's rank correlation coefficient. We know about mathematical methods of correlation coefficient, in which in last lecture we have studied Karl Pearson correlation coefficient, where variables under study are capable of quantitative measurement, but if they are not, then they should be arranged in serial order, and for this we are using Spearman's rank coefficient of correlation, and this is denoted by letter P pronounced as rho, and this is the formula for Spearman's rank correlation coefficient, where 6 is the constant value, capital R for the rank correlation coefficient, D is for difference of ranks between paired atoms, and N obviously total number of observations. There are three basic ways for calculation of this Spearman's rank correlation coefficient, in which first case where ranks are given. For this we have to do three steps. First, compute the difference between rank R1 and R2, then square the D, get D square, and finally substituting these values in formula. Where the another way, when ranks are not given, then we have to give the rank as highest one and lowest, and the next lowest is as a 2. And the third method, when the ranks are equal or repeated. Moving to ahead, for first type where ranks are given, then what will be the outcome of the results? Here an example is given for titrable acidity number from this Aristolochia at different time interval. So just we have to do further calculations for D is equal to x minus y and D square, and last one, that is the summation of D square. Just put the values of your first variable, that is the rank of rank of time. From this you will get x minus y and its square in the last column, and there is a need to do summation of this column so as to we get summation of D square. Just put the values in the formula, then you will get the Spearman's rank correlation coefficient when ranks are given, means data is arranged in either ascending or descending order. So here what will be the conclusion? As the value is negative, so here the conclusion is that variables are in opposite direction, so there is a negative correlation. As we know about the three types of correlation: positive correlation where values are positive and variables are in same direction; in negative correlation they are in opposite direction, and when there is a zero value, then there is a no correlation. Then the second formula, that is ranks are not given, where we have to do the further steps. Here that can be explained best with the help of this example. Here one variable is fruit and number of seed in that specific fruits. So we have to calculate Spearman's rank correlation coefficient, but here we can observe that these values are not arranged in any ascending or descending order. So what we have to do, we have to give them ranks, right from highest to the lowest. So here we are giving the ranks highest value for the fruit, that is 90. So we have given rank 1, and then so on 2, 3, and then 4, and then 5. And the same case or same type of steps we are following for the y variable, that is seeds. Here also we have to give the ranks from highest to the lowest, 1 to the 5. And then what is the next step? So again one table should be there which indicates the ranks for the x variable, and here the ranks for the y variable. And the next column is our 2D, that is x minus y. But here what is x and what is y? X is your rank and y is your rank for the seeds, that is y variable. So here just 2 minus 1, you will get 1, and so on for all the calculations. And last column, that is d square, so that you will get summation of d square. Again by putting the values in this given formula where n is equal to number of observations. So we are with 5 observations. By putting values we will get this answer. So here conclusion, as the value is positive, so there is a positive correlation between fruits and seeds of a custard apple. In the third case, where ranks are equal or repeated, then there are few different steps than the previous two methods. When there are 2 or more atoms have equal values, then it is difficult to rank them. So what we have to do, just we have to give average of the ranks they receive. Suppose if 2 individuals are at 5th place, then what we have to do, just calculate 5th and 6th value and divide it by their number of observations, and they are 2. So what will be the rank? That is 5.5 for 5 also and for 6 also. And the next will be, instead of 6 it is 7. This is again true for if these values are repeated for 3 times. So here also the same criteria. So 5, 6 and 7 for the 3 repeated ranks, and the next will be 8 instead of 7. Then for this again similar columns are there, where the second column is for rank for the x and fourth column, that is rank for y. So in this column what we can observe, that 17 value is repeated for the 3 times. Okay, so here the rank is first value is our 10, so its rank is no doubt 1. So 17 is repeated for 3 times. So as per the our knowledge, it is 2, it is 3, and it is 4 when we are considering or giving them rank. But for this example, what we have to do, just do sum of these 3 values, 3 plus 2, 5 plus 4, 9, and divide it by 3, so you will get 3. So for all these 17 repeated values, the rank should be 3 instead of 2, 3 and 4. And then the next rank is 5 instead of 4. Okay, and the similar here also giving ranks from 1 to the higher ranks. So this 14 is repeated for 2 times. Okay, and another one we are observing, that is 0.7, it is repeated for 2 times. So as per the ranks, it is at second rank and this is at the third. So just sum these values and divide it by number of observation. So here 2.5 is ranked for second as well as the third, and the next is 4. Okay, but here it is not true or not 3. Instead of that, it is a 2.5, 2, 3, and next 4, then next is 5, 6 and 7, but these values are again repeated. So what we have to do, again we have to multiply, that is 5 plus 6, that is 11, divided by 2, so we'll get 5.5. and then the next value, this is 5.5, that is 5, 6, and the next value is 7, and so on. Okay, then the next column is same as previous example, that is d is equal to x minus y. So what is our x? That is rank. Note down, that is x is rank and y is also rank. So here we are getting this d, from that d square, and finally summation of d square. So in brief, in x series 70 is repeated, so here m is equal to 3, and for y series 14 and 7 repeated twice, so here n is equal to 2. The formula for this calculation is vary because m and n, here no any directly a single n we are using, so this is the modified formula for that, and by putting these values, but here n, capital N is your total number of observations, and m, that is for x series, and small n for y series. So p is equal to 1 minus 6p, that is just pronunciation is rho is equal to 1 minus 6, and so on. Just by doing this calculation we will get the answer p is equal to 0.73. so here, as this value is positive, so there is conclusion that variables are in same direction and there is positive correlation between x and y. So up to this, just remind some points, that is Spearman's rank correlation coefficient, again carried out by 3 different steps when ranks are given, when ranks are not given, so we have to give them rank, and the third possibility, that is ranks are equal or the repeated. So this is all about Spearman's rank correlation coefficient, which is the mathematical method for calculation of correlation coefficient. In next lecture we go for credit second, in which we are going to study designing of experiment with the help of different types of designing of experiment and principles of designing of experiment. Thank you.